One of the things I've received a lot of questions on is how to properly convert these kinematic curves from one to the other. So position time to velocity time to acceleration time, velocity time to position time, going back and forth. So going up and down this list, so to say. I'm going to start with a position time example and then show how to work down to the velocity and then the acceleration time, because I think that's a little bit easier. And that is all based on this little chart that we have over here on the right side. So I definitely recommend you're able to draw that. And if we just recognize that when I'm moving down from one graph to the other, so when I'm moving down, oh, lovely. All right, when I'm moving down, anytime I'm moving downwards, I'm always on the slope side. So that means I'm going to look at the slope of a position time to get the velocity and the slope of a velocity to get the acceleration. So what I recommend you do is I kind of take a look at these inflection points, or these points where you have like a change in slope. So if I add some lines in here just to make sure we are consistent with those changes, we just have to analyze the slope. So anytime you're moving down this list, we're going for a velocity or acceleration from a graph above it, we're going to look at these slopes. So one of the things I like to do is I like to kind of actually draw in the slopes at these different points, which I will do now. And then I just look at them. And what we have to realize is that is a positive slope because it's slanting upwards. A horizontal line is zero slope. And from left to right, anything that's kind of slanting down is a negative slope. So based on that, we have a positive slope, zero slope, a negative slope, zero slope, and positive. Now, sometimes people get thrown off because that is a negative point, meaning if I literally read that off of the y-axis, I get a negative value. We don't care about the actual points, however. We care about the slopes of these points. All right, so once I have that, I'm just going to move down to my velocity time, and I'm going to say, well, this first point at 0 seconds of time has a positive slope. So that means at 0 seconds of time on my velocity, I'm just going to make a positive value. For the second point, I have a slope of 0, so I will just make sure that I have 0 velocity. Then I need some negative velocity for the third point. Again, that's because I have a negative slope here. I then have a 0 slope, so I make sure I have 0 velocity, and that last one there is positive, so I'll make sure that I get some positive value. All right, once I have those points, you can probably see where this is going. All I need to do is connect those with some kind of line. Okay, so this is what the correct velocity time graph looks like. And now moving downwards, well, same thing, I'm going to look at slope. But what I need to recognize here is this first section here. That slope is constant, it's not a curved line, constant and negative, followed by positive and constant. So if I want to show that, that's a little bit simpler. I've got negative, so I go to the negative region, and it's constant, so I have no curvature, I have no slope, and then I have a positive constant slope. Okay, so all I'm doing is I go from a position to a velocity to an acceleration. Since it's always on, this side moving downwards, I always have to be looking at the slope. So that's hopefully straightforward. We'll look at another example now just to make sure you guys understand. All right, I'm going to add in, again, these. I wish I knew how to use this iPad. We're going to use these inflection points here. So this is where those slopes kind of change from positive to negative or negative to positive. Okay. Again, if I'm moving down, I'm only ever going to look at the slope. So let's go ahead and let's look at some of these points here. And I'm going to go ahead and I'm going to draw in what the slopes are at those locations. So this first one is kind of horizontal. Then we've got upwards, horizontal, downwards, and it ends off horizontal. So that is 0 slope, positive slope, 0 slope, negative slope, and 0 slope. Now I'm just going to go ahead and put those points on my velocity time graph. So at 0 seconds, I have 0 slope or velocity, followed by positive, followed by 0, followed by some negative value, followed by 0. And then I can go in and I can connect these. And just like that, I have the correct velocity time graph for that provided position time graph. If I want to go down and do the acceleration time, well, I have 3 different slopes here. I've got 3 different slopes. I've got positive and constant. This whole section in the middle is negative and constant, and then this last section is positive. Even though it's in the negative region of the graph, if I read those values, the slope is still positive. So if I want to do that, then I can go ahead and I can make these connections. Positive and constant. For the middle two sections, it's a negative and constant, followed by positive and constant. And then we can kind of connect those with vertical lines, just out of standard practice. All right, so anytime you're going down, you only look at the slopes because you are always on, oh my gosh, you are only on the left side of this graph. You're moving downward, so you're always going to be looking at the slope. All right, where I think a lot of people start to run into an issue is when we want to look at how do I go from a velocity to a position time. So before we get there, again, I'm going to add these. Okay, you'd think I would have figured this out by now. We're going to add these kind of inflection points where the velocity flips from positive to negative or from speeding up to slowing down. Before I get into moving upwards, we know, just like the previous examples, if I'm moving downward and I'd like to get my acceleration, I'm just going to look at the slope of my velocity time graph. All right, so based on that, this entire section has a negative constant slope, and this section has a positive constant slope. So if I want to go ahead and make my acceleration time negative and constant, followed by positive and constant, I'm already done with one of my graphs. To go upwards and get the position time graph, it's a little bit more difficult, but I'd like to show you what I do. I no longer look at the slope. I look at the specific values. So I'm going to draw some dots where my actual velocities are, and I'm going to read the graph. That's how I get velocity from a velocity time graph. So I'm no longer looking at slope. I'm looking at the points. That is a positive velocity because it's literally above the x-axis. That is 0. That is a negative velocity, and that is a 0 velocity. All right, so what we need to recognize here is if I want to move upwards, we're going to want to be able to fill out these 6 descriptive slopes on the side. And what I mean by that is if I want a positive constant slope on any graph, it's going to be a line that's just moving upwards like such. Negative and constant is going to look like that. The other 4 are a little bit tricky, but you need to make sure you understand how to do these. So positive slope to 0 slope means I have to start with a positive upward slope and gradually curve until I have no slope. 0 to positive is the opposite. Start with no slope, a horizontal line, and then curve over time to become more positive. Negative to 0, well, negative, I start going downwards, and then I curve to 0. And 0 to negative, start with a horizontal line, no slope, and curve over time to get a negative slope. If you understand how to draw all of these, here's how you make the connection. This first section here goes from positive to 0. So I find my positive to 0 curve, and I just make sure that I draw that into the first section. So I'm literally noticing that it's positive to 0, so I drew my positive to 0 curve in that section. In the second section, I go from 0 to negative, so I find my 0, that's not the right one, my 0 to negative, and that's what I'm going to add in this next section. So I'm going to continue this over, and I'm just going to add the 0 to the negative section. And last but not least, I go from negative to 0, that is this section, so I'm just going to add that piece in here. Now, it doesn't really matter where on your position time graph you draw this. I could have done it up here. I could have done it down here. All of those are the same graphs. Those are just occurring at different positions or different locations in space. All right, but if you can draw these out, it's almost like putting a puzzle together to get that position time graph. So we'll try another one. All right, so we've got our curvatures in there. I highly recommend that you get to a point, and of course I still don't know how to use this iPad. You get to the point where you can draw those out on a piece of paper and get them right every time. If you cannot draw those curves 100% of the time, 100% correctly, you are going to run into some issues. So again, let me show you how we go about this. I'm going to go down and make the acceleration time graph first because I think that's a bit easier. So I know that that's going downwards, so I'm going to look at the slope. Well, I've got 3 slopes. Negative and constant slope, positive and constant, negative and constant. So the first one occurs over the first section that is negative and constant. The second section is positive and constant, and those last 2 sections have negative constant slope. So my acceleration time graph is done. Now what I'm going to do to make the position time graph, well, I'm going to go ahead and look at my individual points, my values of my velocity. Not the slopes, the values. So I've got a positive velocity, 0 velocity, positive velocity, 0, and negative. Now I'm just going to look at it section by section. I go from a positive to a 0 velocity, so I want to go positive to 0. So I'm going to go ahead and I'm going to stick that in to the best of my ability. I then go from 0 to positive in the next section, that is this one. So I'm just going to add that piece in. I then go from positive to 0, so that's going to be this section again. So I'll try not to run into my title, but I'm going to do that. And the last section goes from 0 to negative, so I need to tack this one on at the end. So start with 0 and become more negative. All right, so if you approach it in this direction, going downwards like this should be fairly straightforward because you always look at the slope. What I recommend is you kind of use these different slopes, maybe make yourself a little key on the side of an assessment or a worksheet, and then you just kind of have to piece them together like a puzzle piece. So this first one here was this piece, this second one here was this piece, this third one once again was this piece, and then I just tacked on that last one. And you can use the values of your velocity time graph and the values in your descriptors to actually make sure you're choosing the right section.